Hello everyone. So today yet another BSP program. So the program is solving system of linear equations represented as a matrix of form Ax equal to B. Okay. So this is the thing which we want to do and what we intend to do by the way. Okay. So there are so many methods to solve a system of linear equations and the prominent methods are in your electrical sciences you might have used Kramer's rule, right? And then there is a substitution method and all, but in MATLAB we have a few options. Okay, so what options do we have by the way? So one is the popular using the inverse of a matrix. Okay, that is one method. Then there is something called as row reduction echelon form, or the Gaussian elimination as we call it. Then by default, MATLAB tries a least square method, if at all, in case you want to do, directly. Then there is something called as LU factorization. Okay, so I am just interested in this particular method, using inverse of a matrix and then to some extent Gauss-Jordan elimination because we have it as a part of theory. And then there is these two methods. Okay, so I will not be talking much about them. Hopefully, as and when we come across the topics in theory, all the dots will be joined. Okay, but I want you to be curious and try all the methods, Google them individually and see which one performs better. Okay, because on our notebook we usually do a 2 cross 2 matrices or a 3 cross 3 matrices, but when the unknowns are large then it's a different ball game altogether, and maybe we never know. Okay, so that's why different sort of different types of methods have been studied by uh, you know and they have been part of MATLAB also. Okay, so what are we going to do by the way? So yes, that's our intention. Explore various methods. We will do at okay. We will do know how to do those methods in MATLAB rather than the actual theory. Then of course, this is also one more task. Explore the advantages and disadvantages of individual methods in terms of computational complexity. No, we are not doing it here in MATLAB, but I want you guys to go through explore textbook linear algebra, or you can try some various sources on internet. All of these are popular methods. Okay, so your time, and I want you guys to relate, okay, a problem of system of linear equations and its solution to some real world scenario. Okay, so let us see what is the first method here. Okay, the first method that we will be talking about is the row reduced echelon form. The reason, or it's also called as Gauss-Jordan elimination. Okay, so the ready function that MATLAB uses for this is rref. Okay, rref readily gives you the matrix. You give the matrix, it gives it to in a row reduced echelon form. Okay, and why I took this particular method to begin with is the method clearly reveals what is the nature of the inputs that we have given, whether our matrix that we have given, the linear equations can be represented as matrix, whether it is consistent or inconsistent, whether the solution exists or not, whether a unique solution exists or not, or are there any infinite number of solutions to this, or there are no solutions at all. Okay, so that's what we are trying to explore, and this Gauss-Jordan elimination sort of helps us here. Okay, so there are some innocent commands in MATLAB which gives us the answer, but we are just sort of trying to explore how to give inputs. Okay, shall we? Okay, so here I have written this particular program for a 3 cross 3 matrix. Okay, so what is it by the way? Usually, so if at all there is a system where you are having two unknowns, then usually you have need two equations which are having enough content in them. Okay, so let me formulate a problem here. Let me type in here. Say I have a simple task. Okay, so there is price of a one pen, let me call it as an X, okay, and price of one pencil, okay, shall I take it as a pen as, okay, I will take it as X, and price of a pencil is, what shall I take, a P, okay. So this, let me call it as price of a pencil. Now I have been given two problems here. I have been given two problems. So first equation that has been given to me is one pen plus one pencil. It costs me how much? 14 rupees. Okay, one pen and one pencil cost me 14 rupees. And say three pens, 3 into X plus no, how many? One pen plus one pencil cost me 14 rupees. Three pens and two pencils. Okay, three pens and two pencils. They cost something like 38 rupees. Okay. Now you can see here is a scenario. I have been given, there are how many unknowns? The price of the pen, the price of the pen, and the price of the pencil. They are the unknowns. Okay, this is a scenario. This is a scenario, and we're gonna solve this particular thing, and we're gonna find out the price of pen and pencil. What we have been given? We have been given two linear equations containing two linear equations containing two variables. Okay, now shall we try how do we solve these things? So the method for reduced echelon form is, first thing you have to enter the matrix. Now do not give any heed to this particular thing. Let me just go ahead and run this particular first and second command. Now you can see here, first what should I enter in A? Any idea, folks? Any idea? So elements of first A, I have to enter them as the first line here. This coefficients of X and P in equation 1, they form the first two rows, first two columns of row 1, and 3 and 2, they form the uh, two columns of second row. Okay, so this first one is 1 space 1. Okay, that's the first one. 3 space 2. That's the second one. Okay, so wait a second, what just happened there? 1 1 3 2 invalid expression. What just happened? What did I do? Okay, the second elements of rref. Okay, so there is this command rref which has popped up here. Okay, sorry. Let me just okay, 1 1 colon, what's the next number? 3 2 2. Okay, so what is my matrix A? Now you can see this one here is my matrix A. Okay, so are you getting the feel? X plus P equal to 14, 3x plus 2P equal to 38. My matrix A contains the coefficients. Okay, then my matrix B, this is nothing but the answers here, the last column 14 and 38. So here I will give them as 14 colon 38. Okay, so that's my B. Okay, so you can see here, so there is my matrix A, then there is matrix P. So I have represented this particular task of two linear equations in terms of matrix A and B. Now what I will do for the RRF method, I am going to represent this particular thing as an augmented matrix. So what is that thing? You can see here, I am going to concatenate matrix A and matrix B sideways. Okay, now you can see, let me do this thing here. Let me select and let me do this particular thing. Okay, so now did you see what happened? Now I have the matrices here. Okay, you can see this is my matrix A and this is my RHS represented as now concatenated. Now what is a row reduced echelon form? Now what this RREF does, it converts it in a strange form. Okay, now let me run this particular command where I have given this augmented matrix, and here you can see I have the answer here. You can see This is what is called as row reduced echelon form. You can see the diagonal elements have become 1, other elements have become 0, and the answer lies in the third column. So is the answer correct, by the way? Now this particular solution says that my answer, the price of the pen, which is X, it is 10 rupees, and the price of the pencil is 4 rupees. So do you agree? Yes, I guess, right? One pencil plus one pen equal to 14 rupees. Yes, 10 plus 4. Three pens is 30 plus 4 into 2. Yeah, that's 38. So there is the solution. Okay, this particular column, the third column, usually gives me the solution. Okay, is that fine? Okay, so that's the method, the row reduced echelon form. Okay, what is the second popular method, by the way? So here, okay, what is the second popular method? The second popular method is, first you find the inverse of a matrix. First you find the inverse of a matrix. Then afterwards you multiply both sides of equation with the inverse. Say you have matrix AX equal to B. Then what you do is, suppose I multiply on both the sides by A inverse. So what's going to happen? A inverse into A. This is going to be identity matrix. Then multiplied by X. Identity multiplied by X is nothing but X only. Here what I have to do? A inverse multiplied by B on the right side. Okay, let us do that. The second method. Let us do that. The second method. Okay, so here this INVA, it's a command to calculate the inverse. Now this one here you can see, this is the inverse of matrix A. Now what I will do? Multiply the inverse with B. That shall be my solution. Okay, yes, the second method also has given me the same solution, 10 and 4. Okay, now what is the least square method? Here you can see this particular strange command, the slash or the backslash, what you call it as. Okay, now that usually does the least square method, or you also have the command here. So what you have to do here is, you have to take the matrix A, then the matrix B, and then you have to use this particular operator here, and directly you will get the answer. Directly you are going to get the answer. Yes, okay, now you can see it took it as a fraction. Okay, there is a mysterious way in which least square method works, okay, which I do not want to go into correctly. Okay. Even I am confused about it. Then there is using LU factorization. So the command for that is linsol. Okay, the command for that is linsol. Now let's try this method also. Did you see here? I am avoiding the semicolon here so that my answer directly displays in the command window. Okay, even this method works. So which all the methods are there, by the way? You can use either the command linsol, otherwise you can use this particular slash, okay, the black backslash, okay, or what you can do is, you can use the find the inverse and multiply B with an inverse to automatically get the inverse. Or what you can do is, you can augment the matrices and convert the matrix into a row reduced echelon form, and you will get your answer in the last column. Okay. So that is straightforward. Okay, now I just told you one thing. Okay, how to formulate a problem here. Okay, so and I took this particular example, a pen, a pencil, and a, okay, two linear equations. What if I add what if I add one more parameter? Okay, let us have a pen, a pencil, and a eraser. Okay, so I will call eraser by an R, and let me assume in my mind the price of the eraser is, say, 1 rupee. So that makes it a 15. Okay, so three pens and two pencils, and let me have how many erasers? Let me have three erasers. Okay, now the price is, what will be the price now? Three pens is 30 rupees plus 2 pencils, so that is 38, 39, 40, 41. So that is 41 rupees. Okay, now how many unknowns are there? So I need three unknowns. Okay, now three unknowns. Okay, so when there are three unknowns, now please tell me, are two simultaneous equations sufficient to get me the value? No, right? Definitely not. So when number of unknowns are three, then you need to have at least three simultaneous equations. Let us form a third one. What shall I say? Say 2 pens, that's 20, and 2 pencils. How much is that? 2 pencils, 2 pencils, 2p. That is how much? 2 pens and 2 pencils. No. Let me take 3 pencils. Okay, 3 pencils. Okay, 3p and plus 2 erasers. Okay, let me take 5 erasers. 5r. Now, what will be the price? Somebody telling me here. 2 pence 20, 32, then 33, 34, 35, 36, 37. Okay. Now there. I think it's fine. So to find three unknowns, we need at least three matrix 3 by 3 or three equations. Now let us get started here. Okay. Now let us get started. It always helps when you are expecting a answer. Okay, we only formulated the problem. Now let me convert this particular problem statement into an equation. So 1 space 1 space 1, that is the first coefficient, and the first line, then 3 2 and a 3, that is second line, then 2 3 and a 5, that is line 3. Okay, there I see I have my matrix A. Now let me have, okay, these commands are okay. Wait. Now let me make the change here. Okay, enter the value of the, not a square matrix, matrix of B. Okay, value of matrix B. What should I say? Of size. What should be the size? 3, comma 1. Okay, this is fine. I guess this is fine. Okay. So mistakes happen. Okay. Yes. Now let me there. Okay, it's asking, so what should I give here? As I told you, I should have a 15, then a 41, then a 37. Okay, so let me try. So what do I need? A 15, 41, and a 37. Okay, there. Now let me concatenate both sideways. Okay, there you can see that's my problem formulated. Now let me tell you, now let me use the command rref. Let me do this. Let me go ahead. And what just happened? Okay, I got this particular thing. What is happening here? Now observe keenly here the nature of this particular matrix. First 3 cross 3 matrix. You can see here the diagonal elements are 1. All the values above the diagonal elements are 0, and the one below are also 0. Now that's called as a row reduced echelon form. And then by concatenating the matrix and performing those rref eliminations, you have got your answer here. Do you agree with this answer? A pen costing 10 rupees, pencil costing 1 rupee, and an eraser costing 1 rupee. Okay. Not bad. Okay, so there you can see you have got the answer. Okay, there you can see you have got the answer. Now what about the other methods? They all work well. Let me show you the inverse of the matrix. Okay, you find the inverse. What is the inverse of this matrix, by the way, of matrix A? uh, Here, that is the inverse, then you multiply it with x b. So you should technically get the answer here itself. Do we? Yeah, we got the answer. It's 10, 4, and 1. That was then this third method using least squares. Okay, there you can see. Yeah, this also works. It also gave me the same answer, and then finally the LU decomposition, the lin solve. Okay, so this should give us the same answer. Okay, so these were the 4 methods. Okay, 4 very interesting methods. Okay, now what we want to do is, now let us go slightly off bit. Now let us go slightly off bit, and let us see what can possibly go wrong. Okay, now let me change the formulation a little bit. Okay, now let me change the formulation a little bit. Okay, let me include some irregularity in the matrices. Okay, so here what I have taken, so one pen plus one pencil, one eraser, that's 15 rupees. Three pens, two pencils, three erasers, that's 41. Now here, two pens, two pencils, and two erasers. Okay, so what would be that? We know the price, right? Two pens, two pencils, and two erasers. That should give me how much? Uh, I think a pen costs 20 rupees. Then pencil costs 28. That's 30. Okay, now shall we try? Now, what is the problem here with this? Now, do you see some problem here? Let me just show you. Okay, I have still have three equations here. Okay, and all three equations have all three variables, but there is a catch. There is a catch. Now let me just show you. Okay, let me enter the first matrix here. So that's a 1 1 1 colon 3 2 3 colon 2 2 2. Okay. Now do you see what is the problem here? The column 1, row 1 and row 3, they are highly correlated. 2 multiplied by row 1 subtracted by row 3 straight away eliminates row 3. That means there is a redundant equation, and even though there are three equations, I am I doubt if at all we are getting any answer here. Okay, these sort of equations are sort of inconsistent. Okay, the matrix, what we call it as inconsistent. Okay, 15, then 41, then a 30. Okay, now let me augment this. Let me do this, concatenation, what we call. Okay, there, and you can see in this particular case. Okay, now what just happened? Now we can see here. Did we get the column, the diagonal elements as one? No, no, no. The third element, it did not turn out to be one. And wait a second. 11 and 4. Now, does that work for us? Does this equation values work for us? If this is to be believed, this third column is to be believed as a solution, then price of the pen is 14 rupees, price of the pencil is 4 rupees, and eraser is free. Does it work? Let us see. See here, x. Okay. So if this equations are to be believed, this is my X, the pen price, this is my price of the pencil, and this is my eraser. So price of a pen plus price of a pencil and a free eraser, that's 15. Agreed. Three pens are 33. Two pencils are 8 rupees. Now that is 41. Agreed. Okay. And here this third one, two pens is 22. Two pencils, uh, 8 rupees. Two erasers are coming free. That is 30. Okay, so not bad. Okay, so this particular formula, you can see it was working for a price of a pen and the price of a pencil and price of eraser equal to 5, or it was a price of pen, pencil, eraser equal to 15. It was working, and whatever may be the combination, it is still working. Okay, so you can take the price of the pen as 11, price of the pencil as 4, and eraser free, there also it is working. So why that just happened, by the way? Okay, I am glad. Okay, so you can see the row reduced echelon form, it has given one of the solution, but this particular matrix is, I would say, sort of inconsistent, because three values, several values are giving same solution. So that's why I would like to say you, any matrix just formed, anyway, is not going to be wait a second. Here we are. Okay, so uh, for any equation just like that, you cannot get the solutions. Your system, it has to be, you know, uh, it has to be cleverly formed. Okay, it has to be cleverly formed, and the rows and the columns are supposed to be independent. Okay, now that was row reduced echelon form. Now should we try the other forms? By the way, finding an inverse. Now shall we find inverse of this matrix? What is matrix A? Once again, as I told you, the matrix is sort of spooky because using row reduced form, you can see first column and the first row and the third row. They can be, they are highly related, and mere subtraction is going to eliminate straight away one of them. So what does the inverse say? Now, does this thing has an inverse? Does this thing have an inverse? Let us see. There we are. Okay. So when you say you are having an inverse, you take the matrix, multiply by inverse. A unique identity, a solution exists only when you end up getting an identity matrix. But here you can see, now this particular case, the inverse is giving me strange results. So that is why I'm not getting the answer here either. So at least the row reduced echelon form, it gave me partial solution. Now what about this particular method, the least squares method? Okay, because this does not involve finding a inverse. Okay, this does not involve finding an inverse, so I think that should be fine. So usually the infinity has got something to do with determinant, since the determinant usually goes to 0. Adjoint by determinant, sorry, adjoint by determinant, usually 0 goes to infinity. That is the reason. Okay, the least method, the square method also giving not a number. Okay, so this method also does not work. What about this LU decomposition? Now that method, does it work? No, even that method did not work. Okay, so isn't this interesting? So be curious and formulate some different questions. Okay, formulate some matrices of 3 variables and see what all things going to happen, and you will come to know eventually what is a singular matrix and what is a inconsistent matrix. Okay, that's it. Okay, so I do not want this video to be larger. Okay, I will stop this thing here. Let me bye.